Hello, and welcome to the Analog Devices Precision Training video, which focuses on precision digital-to-analog converter technology. This video will go through the details of the key specifications associated with DACs. These include resolution and accuracy. The key objective is to provide an understanding of how these relate to the static performance specifications of a DAC. Before diving into detailed specifications, we will quickly remind you what a digital-to-analog converter, or DAC, is. A DAC, in the most simple form, converts a digital input signal, ones and zeros, into an analog output signal. This is done with respect to a fixed reference voltage value. The reference voltage determines the output range of the DAC. The number of digital input codes of a DAC is the number of possible combinations of ones and zeros. 2 to the n is the total number of possible combinations, where n represents the number of bits. Remember that the least significant bit, or LSB, is the smallest increment in a DAC. The LSB weight is calculated as the reference voltage divided by the number of digital input codes. Full scale is the highest digital output that the DAC is able to output. Full scale translates into a value of Vref-1 LSB in the analog domain. Since no precision DAC architecture is able to reach actual reference value at the output of the DAC. The ideal analog output of a DAC is then calculated as the product of the LSB weight by the digital input. It is important to note that the analog output of a DAC can only exist at discrete levels. As previously explained, these discrete levels, or steps, correspond to the resolution of the DAC. The key specification you need to think about here is differential non-linearity, or DNL. Another key point to note in relation to a DAC is the accuracy. The accuracy represents the difference between the measured output voltage to the expected output voltage, based on the programmed digital input code. Integral nonlinearity, or INL, is the key specification for accuracy. We will now take a look at these two key specifications, DNL and INL, in more detail. Starting out with DNL specification. The ideal step size for each DAC code is 1 LSB. The DNL error is defined as the difference between the ideal LSB step and the actual or real step as one moves along the DAC transfer function. DNL errors translate into step sizes which are larger or smaller than would be expected. In other words, larger or smaller than the ideal step size. This, in addition to the noise, reduces the accuracy of the DAC output. A key requirement of a DAC is that it is monotonic. This means that the analog output voltage should increase or remain the same as the DAC's digital code increases. If the output of a DAC decreases as the digital code increases, the DAC is said to be non-monotonic. The relative accuracy of a DAC is also known as integral nonlinearity, or INL. INL is the deviation of the actual transfer function from expected, which is a straight-line transfer function of the DAC. INL results in the addition of unwanted harmonics and spurs or tones at the output of the DAC. Analog Devices has a large portfolio of precision DACs available, So please check out our website for more details. To learn more about precision DACs, noise, and additional key dynamic performance specifications, please continue to watch our next video in the Precision Training Series on DACs. Click on the link below or go to Analog Devices Precision Digital to Analog Converter